Welcome to Module 3, Lesson 9. So, we just talked about how, depending on where you put those parentheses in the last episode, really determines how the answer of the question goes. Now, the reason why, in that last video, I was keep on saying I'm just going to be using the problems from the problem set is because I wanted to ensure they worked. Because there is this fancy little thing called the associative property. It's different from the commutative property, but the associative property is a little interesting and is kind of breaks the rule if you want to use it of that, but it's its own set of rules that always works, and when this works, the parentheses thing kind of goes out the window, but we'll talk about it in a second. So today's goal is I can model the associative property as a strategy to multiply. Now, I'm using the example of multiply here, but it is more than just multiplication. And I'll give you an example. So, associative property is basically saying, I'm going to use numbers here to represent it. And I'll explain what I mean by that. It'd be like A plus B plus C equals D. So it's saying a number plus a number plus a number will equal a number. I'll give you an example of here. Let's say 1 plus 2 plus 3 equals, 1 plus 2 is 3, 3 plus 3 is 6. Example there. Now, the associative property is saying that I can add AB first, or I can do B plus C first, and it'll always give me the same answer. That's what it's saying. So in other words, visually that you might recognize a little bit, and I think it's a good way of visualizing here, that I can say that A plus B in parentheses plus C is the same as A plus B plus C in parentheses. And we can show that here. Example of 1 plus 2 plus 3 equals 6 is that, I will slide this over just a little bit. If I did 1 plus 2 plus 3, if I did 1 plus 2 first, that would become 3 plus 3, which equals 6. Well, if I were to go on this other side, say 1 plus in parentheses 2 plus 3 in parentheses, this would become 1 plus 5, which is still 6. Now, if you remember from last episode, I was like, hey guys, pay attention. The parentheses do matter. Well, they do. They really do matter, and they matter more often than not. But there are instances where it doesn't. And I kind of want to give you some examples of those. For one, if you notice, both of these problems are adding these three numbers together. If you're adding all three numbers together, the associative property will always work. Same thing with multiplication. It doesn't matter how you multiply numbers together, they'll always equal the same thing. Now, give me an example. I'll use smaller numbers to visualize this for you. But if I did 2 times 3 times 4, using this idea, if I were to put parentheses around the 2 and the 3, I could say that 2 times in parentheses 3 times 4 would equal the same thing. Let's see if it works. So we'll start on this left side first and go down the line. So 2 times 3, skip count by 3, 2 times, that would become 6. 6 times 4, skip count by 4, 6 times. So 4, 8, 12, 16, 20, 24. That becomes 24. So hopefully we'll find out that this side equals 24. Because if it does equal 24, all right, it works. But if it doesn't, that means I'm wrong, and I'm teaching you wrong. And hopefully this is going to be right, correct? Let's see if this works. So starting off with 3 times 4, because that's in parentheses first. So I'm just going to drop down the 2 times part since I'm not doing anything with it yet. 3 times 4 is 12. Now, if I skip counted by 12 2 times, or skip counted by 2 12 times, you would find that your answer is 24. Would you look at that? Do they both give you the same answer? Yeah, they do. And this isn't a fluke. We can do a couple other ones. And I will go ahead and use the problem set to grab one of these examples for you. I could say, no, that's kind of basically the same example. I'll do a more complex one. I'll do 2 times 5 times 6. And we're wanting to say that 2 times 5 times 6, with the parentheses around the 2 and the 5, is the same thing as 2 times in parentheses 5 times 6. do the same process. We'll do this real quick. And if you want to double check my math, please go ahead and double check. But 2 times 5 is 10. 10 times 6 is 60. Now 2 times, I'm just going to drop that down right here. 5 times 6 is 30. 2 times 30, you're doubling 30, becomes 60. Now this works very often, correct? So that means we can say if it's a number plus a number plus a number, a plus b plus c, it doesn't matter where you put those parentheses because it'll always equal the same thing, right? So we could also say a times b in parentheses times c is equal to a times, in parentheses, b times c. We can say that. So it works with multiplication and division, right? Now what happens if you mix them? Let's see what happens. Once again, I will use a problem set problem. So if you're doing this with me, you can actually put this answer down. What if I had 3 plus 2 times 5? With the parentheses around the 3 plus 2. And on the other one, I had 3 plus, in parentheses, 2 times 5. So, going off of what we've done, we would probably want to say that these equal the same, right? I'm going to hold off on that just for a second because our rule is a plus b plus c equals a plus b in parentheses plus c equals a plus b and c in parentheses. There was no multiplication in that. Or a times b plus, times c. You can see we did the addition is equal to the all addition is equal to all addition. And the multiplication is equal to all multiplication. Here we're mixing it up a little bit. So I don't want to just go off and say they are. They could be, but let's go ahead and check it. Let's see if this does or does not work. Because maybe there being addition and multiplication in the same problem might change things up a little bit. Let's see. So 3 plus 2, starting in the parentheses, this becomes 5. So this becomes 5 times 5, which equals 25. And over here, starting in the parentheses, so this is 2 times 5, which is 10, which is 3 plus 10 is 13. We got different answers for this one. Maybe it's a fluke. Maybe this is just random. Maybe they do something wrong. No, that becomes 5 times 5 is 25. This becomes 3 plus 10. So interesting. There's something going on here. That means that this only works, as of right now, I'm theorizing, theory crafting, that if they're all addition, associative property works. If it's all multiplication, it always works. But when you combine multiplication and combine addition together, it doesn't seem to work. Let's try one more. Let's see if this is a consistent thing. Let's do, once again, let me just do a problem down here. Let's make sure, finding one that works for this. Actually, I'm just going to make my own. Let's do 3 plus 4 times, let's say, 7. And parentheses around the 3 and the 4. And over here, 3 plus 4 times 7 with the parentheses around the 4 and the 7. So over here, I'm doing 3 plus 4 first. That becomes 7. 7 times 7. Doing some math brain right here. Double check me on this. But that would equal 49. Over here, parentheses first. Let's get count by 7 4 times. 7, 14, 21, 28. 28. Drop down to 3 plus. This becomes 31. So it's consistent. So we're saying if a problem has addition and multiplication in it, it will not work. Now, I'll take a quick 30 seconds and explain that for you. When we do multiplication, we have a set amount in each group because every group has the same amount, correct? When we do multiplication, it's like I have this many groups and each group has this many in each. So over here, I'm saying I have a total of 7 groups. A total of 7 groups with 7 in each group. Over here is saying I have a total of 4 groups with 7 in each group, and then I have an additional 3 somewhere. I don't have an additional 3 groups, I just have an additional 3 somewhere else. That's the difference between this. So visually, I can draw this out. So this is saying I have 3 groups and 4 groups, so 3, 4, 5, 6, 7. I'm going to make this mildly small just so I don't have to erase too much right now. So this one's saying I have 3 groups right here. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. So this one is saying I have 3 groups of 7 here, 4 groups of 7 here. Altogether, what do you have? I have 7 groups of 7, which is 49. This one over here is showing something different. This one over here is showing I have 4 groups of 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, and 7. And then I just have 3 more off to the side. So 1, 2, 3. So this is saying after I've done my problem here, just add 3 more to it. That's visually what they're talking about. That's how they are visually different. This is 3 groups of 7 plus 4 groups of 7, which is 7 groups of 7. While over here is I have 4 groups of 7 with an additional 3 off to the side. That's what it means. So this makes me ask a question here. If it always works when it's all the way addition, and it always works if it's all multiplication, but it doesn't work when you cross them, will it work if it's all subtraction? Let's see. Let's find that out. So let's say 10 minus 2 minus 1. Let's just keep it kind of simple right now. And I'm going to put the parentheses around the 10 and the 2. We're going to do the same thing over here, but put the parentheses around the 2 and the 1. Now, once again, make a prediction. Will this or will this not work into the associative property? Make a prediction, determine why. If you want to think about it more, go ahead and pause it. But we're going to go ahead and figure it out. So we start with the parentheses. 10 minus 2. So 10 minus 2 is 8. 8 minus 1, you drop that down, is 7. Going over here, 2 minus 1 is, well, 1. Drop down the 10 minus 1 is 9. Okay, so it's not looking good so far. Should we maybe try another one just to make sure? Maybe I did something wrong. Just go ahead and try another one real quick. Because it worked if it was all addition, if it worked if it's all multiplication. So I want to say it would work if it's all subtraction. So let's go ahead. Let's try another one. Let's try 12 minus 7 minus 3. Put the parentheses around the 12 and the 7. And 12 minus 7 minus 3 with the parentheses around the 7 and the 3. Starting over here, 12 minus 7 first becomes 5 minus 3 equals 2. Once again, I am going through this a little quick. I'm going to just kind of illustrate a point here. Over here, 7 minus 3 is 4. Drop down to 12 minus. 12 minus 4 is 8. Interesting. So the associative property works under very specific situations. If all the numbers you're putting together are being added together, or if all the numbers are being put together are being multiplied. It does not work if they're being subtracted. Now I'll just give you this to you as well. It does not work with division either. This is only if all the numbers are being added together or if all the numbers are being multiplied together. So that's what you're going to be doing in your homework, is just double checking that, seeing if that works, finding the ones that do and finding the ones that don't work, so on and so forth. And recognizing why the ones that do work, and recognizing why the ones that don't work. So just kind of keeping that in mind. That's kind of the main point of this. But hopefully this was helpful. Hopefully you guys learned something, and I see you guys in the next video. Have a good day.